Okay, this lesson is a brief review in factoring trinomials. We're going to start with a trinomial with lead coefficient of 1. So when we're factoring something of the form x squared plus bx plus c, we have a lead coefficient a equals 1. So in this case, you see here that a equals 1. So we have a pretty easy time of factoring. All we need to do is find two numbers whose product is 15 and whose sum is negative 8. In other words, what two numbers would multiply to 15 but also add up to negative 8? So you can try, anything that multiplies to 15. You can always start, if you're not very good with mental math, start with 1. 1 times what gives you 15? 15. 1 plus 15 does not equal negative 8. There's no combination of 1 and 15 that will equal negative 8. So I know you get the point of this, but let's say we try 3 and 5. So 3 and 5 will equal 15, but 3 plus 5 does not equal 8. Or, sorry, negative 8. We need it to equal negative 8. So what we're going to have to do here is make both of these negative, because negative 3 plus negative 8 now equals negative 3 plus negative 5 now equals negative 8. So now that we have our two numbers, negative 3, negative 5, I just place them into two binomials. So x minus 3 and x minus 5 are factors of x squared minus 8x plus 15. So this question, that's all I can do with it. That's all I need to do is factor. If this had an equals 0, then the directions would be different. It would say to solve. If it asks to solve, then we set them equal to 0 and we try to factor. Once we get our factors here, we can set each of these equal to 0 because of the zero product property, which says that when you have two things multiplied, a product of two things, one or both have to be 0. So we can set each one of these equal to 0. We get two solutions, x equals 3 and x equals 5. Now in the second example, it's a little bit more difficult. Now instead of having a lead coefficient of 1, we now have a lead coefficient of 6. So a is 6 in this case. So here we're going to have a more difficult time, not more difficult time, but it's going to be a more difficult problem to solve than the one above. When you are factoring and the lead coefficient is not 1, you still find a product, but this time you're finding the product of the first and the last number, so two numbers that will multiply to negative 18, but will add to negative 7. That negative 7 comes from this middle term here. This is actually called splitting the middle term because what we're trying to find is two numbers in order to split this negative 7 up into. So two numbers that multiply to negative 18 and add up to negative 7 are negative 9 and positive 2. When I split the middle term, I drop this first term down, so I keep that as 6x squared. This negative 7x gets split up into negative 9x and positive 2x. So you can tell, so far I haven't really changed the problem at all. I'm just rewriting negative 7x as, the sum of negative 9x and 2x. So I haven't really changed anything. Then I bring down that last term, this negative 3, and this is my new line of work. Okay, so make sure that you always put an x on these two digits. So it's easy just sometimes to put negative 9 and 2 in there, but you need to make sure you put the actual variable x on there because it won't make much sense when you get to the second part. So for the second part, what you're going to do is group the first two terms, and you're going to take out a GCF here. So the GCF of these two terms is 3x. That leaves me with 2x minus 3 in parentheses. Now in the second two terms, I do the same thing. I take out the GCF. Here, it's very, very important that you pull out a GCF here. Even though 2x and negative 3 have nothing else in common other than 1, you still need to pull out the 1. So we're going to pull out a positive 1 here. Once I pull out that positive 1, I'm left with 2x minus 3. Now this is a good way that you can check your answer here because I should have the exact same thing in the expression inside the parentheses. So because I do have the same thing, I know I'm on the right track. So I keep going. All I need to do now is write that one time. So what appears in the parentheses twice only needs to be written one time. I now pull these two together, 3x and 1, and this is my factored expression. So the two GCFs here get pulled out together to become 3x plus 1. Now if this had been an equation and we'd have an equal sign in here, equal to 0, we would continue. We would set both of these up, again, equal to 0. Based off of the zero product property, we would get two solutions here, and our problem would be done. Alright, so that's a brief review of factoring a lead coefficient of 1 and not 1.